Hello, Earth. Welcome to episode 27 of Making Cell, a series of videos where I record myself designing and programming a programming language and environment called Cell. So, this is episode 27. So, if you're just tuning in, you might want to check out this page in GitHub where I describe the project, or you can go back to episode 1. So, we're still in what I call season 1, bootstrapping the basic calls. And we made quite a bit of progress in the last two episodes that I was on a plane. I'm still traveling, but yeah, today I am able to speak. So what I design, so for good or bad. So this is the notes. So we were implementing this function called the splitter, and here it is. And we were done with, excuse me, a lot of test cases covering what the splitter does. So that's really good. I'm actually very happy with how it turned out, because essentially our splitter is our parser, our lexer and our parser. So if we get away with this, I think we can get away without a lexer and a parser. In the end, it was a long function. It was difficult to write it, but it's about 120 lines, and it works, I think, quite well. So we will probably have to extend it if we see a few more cases, but overall I'm quite confident that excuse me, it does what it should. So we now need to basically write two more functions, one for sorting and one for validating these lines of for data. So the splitter takes text and turns it into unabridged lines of for data, and then we need to, after splitting it, we need to sort it and we need to validate it. And I think the sorting comes first, because to validate, one thing I remembered to add here is that there should not be repeated things. So here's the list of things that we need to implement in the validator, which is check that there's no mixture of hashes and lists. That much is clear. Check that lists use only consecutive integers starting at 1. The dot notation, modify unabridged lines. Oh yeah, so if we have excuse me, sometimes you might want to write a list as like this, for example. How can I actually can do it here? List with dots would be first, second. That's one way of writing it. The other way of writing it is like this. So what we need to do is we need to accept this, consider it to be a hash, and sorry, to consider it to be a list, not a hash, because a dot is the text. So if it was a text, then it would be a hash with repeated items. So in this case, we allow it to be a list and then transform it to that. So the validator also transforms it to that. We will do it there. And then, well, maybe we should even do it in the sorter, right? And then check that no repeated keys in hashes or lists. Actually, we had it there, so it's okay. That's for the validator. And if we go to the sorted, yeah, the problem with the, as I left it last time, is that the problem with the JavaScript sorting is that it is not stable. So therefore, we need to basically yeah, I wonder if I just Google around. Maybe in Stack Overflow they have a nice stable sorting algorithm. My connection is not the fastest, as you might witness right now. We'll see. Okay, no internet. What do I do without an internet? All major JavaScript engines now implement a stable array sort. Really? Yeah. But I want this to be able to run in all JavaScript engines. Alt and all. So what do I do? Yeah, so let's just make it interesting. Let's say that we don't have a stable sort. Then what do we do? So my idea was to group things by length. Actually, no, by length. First sort them on the... Wait, actually don't need a stable sort. I actually don't. Why would I need a stable sort now I think of it? Sorry, this whole thing about the stable sort is completely idiotic, because in for data there can be no repeated lines, and if they were to be repeated, it wouldn't be an issue. I think I was thinking of a stable sort because I thought I would be doing like first the first element, then the second element, but I can just do it full on. Let's just write the code. So I get these lines. So we kind of need a function that compares two values. And then so we have the case, they can only be numbers or texts, right? Wait, do we cover the case? Sorry, I'm just jumping from one thing to the other here. I wonder if we're covering the case where in the splitter where we can stringify text and it will be displayed as text. I think we did. Yes, sir, we have it here. Nice, nice, nice. This is fantastic. So let's have the comparison for values. So first go the numbers, right? Type, state sheet type, yeah. Okay, so if type 0 is not types 1, basically we return negative, means that the first one goes first. Type 0 is to be like this. Oh, but wait, here I honestly don't care if it's an integer or a float. I might have integers, I might have floats, right? Because the toNumber if number function or helper, I return a float, but it can still be an integer. So okay, we'll do it like that. And then we have text. Okay, now we have the case where we have either two texts or two numbers. If type 0 is a number, so the smaller number goes first. If that minus the other one gives you, is it a minus b? I think it's, yeah, it would be b1 minus b2, because let's say you have 2 and 3. So 2 minus 3 gives you minus 1. Therefore, v1 goes before a minus 2 minus 3. It will give you minus 5. So you're in the same boat. But minus 3, sorry, minus 3 and minus 2. Minus 3 minus 2 is minus 1. But if it was the other way around, minus 2 and minus 3, you would sum and it would be positive. Okay. Whoa, excuse me. Good. So now we have the case of text to compare two values. Okay, so what do we do? We have two text values. We need to compare the characters, I believe, because we want the lower cases to go up. So we need to basically compare how about the when you have more characters in one or less in other. How does it work? Okay, so normally you just pad the string with blanks. Yeah, that's a good one. Okay, so we would do something like we take the longest length so we iterate we go max of types, sorry, v1 length, v2 length. We take the text that has the longest length. We stop when it's not undefined. And then we have an index. And then we can do something like uppercase and lowercase. We want uppercase let me change the music. I'm not particularly liking this. It is much better. So good. Then if v1, we need to basically determine if it's uppercase or lowercase. Case it was gonna be, I would do v1k the characters. This is the cases rule. So it's basically gonna be, what happens if I do ABC4 undefined? And if I do so this, okay, then I think I can do something like this: v1k or space. Okay, good. And then the cases are going to be chars 0 equals chars 0 to uppercase upper or lower. So now we know which is which. So if the cases we return, if it's uppercase, what would I say? Lowercase goes up. Cases 1 equals upper minus 1, otherwise 1. Now if the cases are the same, I guess that's also going to be a space. I would actually rather do it let's do it like this. If it behaves weirdly, we can always change it. Am I still recording? Yes. So you notice this is quite similar to this. And then we can return something like we can do the typical JavaScript thing, which is the charcoal that, is it? Yeah. Wait, we have to account for the case that they might be the same. Well, we're kind of doing it here because we will return a 0 in that case. So we need to stop. It's not a 0. Like that. And if there's no result, because I guess there are two empty strings, for example, then you would return a 0, saying they're the same, right? Yeah. So you compare, this compares two values. And then we will do the same thing as we did here, but for all the elements, right? Would be like that. Stop not, data times, math max, a length, b length, in this case they're lines. Yeah, because the moment you find the difference, you stop and return, so that's correct. And then we'll do something like elements. You will do, I guess we would default to empty string if there's nothing there, but we'll do it like this. We'll do a, it's undefined. Same with this. We cannot do it like we did here with the or, because it might be a 0, not a string 0. Actually, you know what? Let's be explicit here. Why? This is just too much of an unnecessary difference relying on the quirks of the language. If it's undefined, make it an empty text, otherwise it's v1k, and that's that. See, these things are things I'm hoping to get rid of in cell. v1, v2, yeah, boom, good. So these are the elements, and then I would just do return compare elements 0 and elements 1, and this will stop at the first difference. Could this really be it? I think so. No problem with the stable sorting. All right, we have it. 33 lines, not bad. This can be deleted. So it can be done here. Okay, now it's time for the fun stuff. Yeah, we need to rewrite this thing right now. We're going to make it like this. Wherever here says splitter, what I want to do is I want to change with input, and also something that says function splitter. Yeah, exactly. Well, instead of f, I would just do something like well, let's just leave it at f for now. For now, all of this is commented. We will later uncomment it when we re-implement get and put using the splitter. And so I guess we can do something like this. The result is test f, test input, and then but we need to process the input, right? Yeah. If test f is equal to splitter, and type, the sheet type of test splitter is array, no, input is array, we can do something like test input add the new lines thingy, and then we'll just do something like result. And then we'll just do comment this out for whenever we need to rewrite it. Does it still work? Nope. What did we break? Message split. Okay, what are we doing here? We have inputs. Of course. There. Good. Still works. And if I break it, yeah. All right. No mysteries. Beautiful. Good. So let's just test the sorter. If I give it, what could it be? I give it full bar 1 and full bar, actually, yeah, 2. I'm expecting same thing. So I'm trying to kill a mosquito here. Yeah. If I put all right. If I do the other way around, I still expect the same thing. Interesting. Why didn't we get that? Comparing bar and bar, undefined. Why I get undefined? This is silly. This is a case where both are texts, right? Wait, this function oh, it starts at 1. Oh, yeah, that's the problem. Well, one of the problems at any rate. Okay, still have a problem here. Okay, I'm here. Yes, I'm returning 0 here. Sure. Ah, I'm an idiot, of course. Return the result. Yeah, it was just outside. And this mosquito is faster than me. All right. Now, yeah, No, it's good. I wonder if I made it really slow with all the things I wrote. Well, we'll see. Slow is only when you notice it to be slow, not before. So, yeah. So, yeah, the other way around. Oh, also good. And where do I put the numbers go first? Well, in no circumstance would I have numbers interesting. I would never have numbers and texts at the same level in a valid input, but first I'm validating, therefore I have to be okay with that invalid stuff. So let's just write it. So I do foo yip 1 and I do foo 1 1, and I would expect the 1 1 to be before the yip 1. Yeah, sorry. Okay, so it does it. The same with uppercase. Did you know that Yip is a Dutch name? Now you know. I'm running out of test cases. This was more elegant than I thought it to be, although perhaps it's inefficient. Yeah, I mean, numbers, lowercase, uppercase. If it's the same, it's the same. Honestly, I would just keep on going. This looks good to me already. So let's just go with the validator then, right? There's no mixture. So how would I go around about the validator? Oh, wait a minute. Because if I have dots on lists, that's where I would need a stable sort. You might write dot 1 and then dot 2, but then the thing might return dot 2 and dot 1. Or well, actually, in that case, it would be dot 1 and dot 2 because the values are, you wrote them in the right order. But for some reason, if the first element is 2 and the second one is 1, they will be sorted the other way around. So not even stable sorting would save you there. What would save you there is before sorting, you would replace the dots with numbers. Yep. Yeah. So we need something like the daughter. Yeah. So the only problem is like, what happens if you actually want to use the dot for a single hash as a key of a hash? Then you should, like, it shouldn't be changed to 1, right? Well, you might just want to make a list with one element. But then we're starting to go into readability concerns, because to me, to write the code that says, okay, there's 2 consecutive lines that have the same prefix, and I have Therefore, in those cases that they both have two dots, therefore I consider it to be a list of two. But sometimes it might just be a list of one, and I still want it to be the dot. I think I'm going to be heavy-handed in this one, yes, and consider dots in the context of a key, not a final value, to be a list always. All right, we will do that. Oh, this is going to be an interesting function to write, I think, more than I thought, because I kind of have to hold the position, right? Sorry for the background noise. This is a noisy city I am in. So, anyway, we kind of would keep track. Let's just go it like this. We will go through each of the elements. If P2 is not a dot, just keep on going. Otherwise, if it's a dot, what do I do? I need to keep track of the prefixes. I did something similar to this already before when I was writing the get function, was it? Where I was keeping prefixes, or was it in the puts? I have a faint but still distinct memory of memorizing prefixes, or was I doing this already in the splitter? Or you know what, it might be even in older code that I deleted. I think it was in older code that I deleted for converting 4 data to JSON and JSON to 4 data. I think it was there because it was the same pattern actually. Okay, anyway, so what's the prefix? Because I kind of have to see where I keep on going or not. Maybe actually I can do it by straight comparison without a variable. So I could do something like this. It would be like this. How do you know if you're continuing or not? You would be, you compare if if you're in the first element, the first line, continuing is false. I might refactor this in a few seconds, but otherwise you say, okay, you take an abridged lines k minus 1 and you slice it from the beginning up until I will never get these guys right. ABC slice 0, the amount of characters. Okay, so let's say we're comparing the kth element, so 0 0 would be nothing, therefore I compare everything. Okay, so it would be from 0 to k2, and the actual line from 0 to k2, and if they're the same, so let's just do it like this. Let's keep the split, it's just too much logic. they're the same, yeah, if they are the same, and what happens if they're the same but you have like some text there? Okay, they're the same and abridged lines k minus 1. Actually, we can do it like this. Last line and abridged lines k minus 1. So we could do something continuing. And last line k2 is not text. If we're not continuing, we go to unabridged lines k2 1. Else we replace it on the spot. Functional programmers rejoice. Look at that. So we have the D daughter here. Let's see if it runs. It runs. Not bad. Okay, I'll take a break. I'll be right back. Okay, so let's just test this function. So if I do something like sorry, yeah, good song this one, huh? I'll put it again, actually, it's really good. So I'm expecting this. The daughter, yeah, return, yeah. If I do yeah, what's the problem? Of course, it's a 1. That's what I wanted to test. Sorry. And then blank. Oh, nice. Nice. It really worked. Let's just do one with sorry, some more. No, like this one. All right. Yes, okay. This works. Always I'm testing the tests. So we have the d-daughter. So we do splitter, d-daughter, sorter. This d-daughter should go before. So let's just respect the order. Nice. We're not ready for the validator because we have the dots already. So this is done. So how do we check, for example, there's no mixture of hashes and lists? What's an efficient way of doing this? The mixture can only happen in 2 lines, because in 1 line there can be no mixture. So it entails comparing the current line to the previous line. Oh, sorry about that. So just compare to the previous line everything, right? Wait, not compare everything. What's everything? Let's just write it down. So if I do something like this, is what's illegal? To do this. And this is what's wrong. So you have a prefix in common, and then I see. So you basically take the common prefix between 2 lines. At the point where they fork, if they only fork out at the last element, by forking being different, well, I guess you can tackle first two lines that are the same. So just, well, it's not just 2 lines that are the same. It could be also the same up to the next to last one, in which case it also is wrong. Yeah, just let me think for a second. I feel like I started to smoke, but I'm not smoking. So how the hell am I going to do this? I guess we can chop off the last element, because the last element being a value we don't care about. If they are the same or different, doesn't matter. We're looking at prefixes. The value can be whatever it wants, right? No, it cannot be whatever it wants. Because, for example, what happens if I do something like foobar is 3, and then foobar yet something? In this case, well, we have a lack of compatibility here, but what about this? You have a final value, and I'm starting to think this function is going to give me more trouble than I thought. What's going on? Okay, let's at least agree on what should be the issue. No repeated keys. List only use consecutive integers starting at 1. Yeah, so you cannot use like a non-integer and also jumping integers. Actually, jumping would be okay if you want to say the 3rd element and the 5th element. I actually am okay with sparse arrays. It's powerful to do that. Why not? You cannot do it with dots, but you can do it with numbers. Takes a tough cook to make a tender chicken. So parse lists are okay, so in that case you need to compare to check for duplicates across multiple lines. At least it's sorted. That really helps. So you can just look backwards, right? Sorry, I'm just thinking everything at the same time, and that's why I'm not getting anything done. There was also a fourth rule, which is something about the fork point. Fork points cannot be values. So keys are all the elements of the path that are not the last one, and values are the last elements of each path. So the fork point is where two keys become different. Okay, I think we just need to write test cases here, because else I'm going to go insane. So something like this. Foo, maybe I can finally see the pattern of the implementation through the test cases. So if I do foo yip I will expect an error that says yeah, the error would say path for yip has no value. Yeah. So why do I determine it has no value? Because if it was just foo yip, it would be okay. It would be just fine. So what's the problem here? The problem is that here you have length 2 with this prefix, and here you have length 3. So this is interesting, because you also are comparing previous lines. Okay, so that's the fork point. Actually, it's not a fork point. It's more like foo yip. If you have a foo yip, there cannot be. Sorry, I was just. Yeah, that's. The problem is that foo here. Foo would be a text. If you look at the key foo, it would just point to a value. But foo cannot point to a value that is a text and then to a value that is a hash at the same time. That's what we're looking at here. That's why this is invalid. So what do I do now? And the same thing goes for this rule, right? You cannot mix hashes and lists. So it's basically no mixture of single and multiple data types. So these two really fall in the same category. It's like it should be clear any prefix on a path, a prefix being a list of contiguous elements from the left to a certain point on a path, should clearly have a single type, what it points to. They cannot have two types at the same time, and these two are instances of that. So there's no issue with the text and number in between them because they're the last element, but the lengths have to be consistent. And that's where we get to these fork points, which is not a good name at all. It's just to me it's reflective of muddle thinking on my part. So no mixture of hashes and lists, sure. So then no repeated keys. The repetition, I'm looking for something that is easier to do. The repetition will be two lines that are the same. No, it could also be, it could be more than that. It could be two lines where the next to last, up to the next to last is the same, and then the last one is different. So basically you cannot have two lines with the same full prefix. Yeah. This is tough. At least I am finding it tough. So what if we write a few more test cases? So if yep. Yeah, this is expected error. The path foo is both hash and a list. But it can only be one of those. And actually here will be the path foo is both single value, yep, and in this case it will be a hash, but it can only be one of those. That's a better error. And same should go with like this. So I should be able to add that. And same with this one. So it's not just the first path element, but a number of them. Could be two. I'm thinking, I think we could do this one. Oh, so if the type is an integer, no, the integer is fine in any position. It's float and k2 equals the length. No, actually, a float can only be a final value. Actually, we'll just return v2 here. Yes, we return we'll do v join. This is it as a key. Integers. Texts are okay. Integers are fine. There's no way of getting none, I think, because it's to number. If number, well, we'll see. No, I think it cannot return none because we are really strict here with what we allow. So yeah, always on minus and digits and dots and more digits. It always has to be a number, unless it's so long. I don't think so. Then this will always return a number or text. So it's only three types in Taishi parlance, well, not parlance, but usage, which is integer, float, or text. And that's it. That's all she wrote. So we have so then we are going to leave this, I think, for the next episode, where we're going to do these two things, checking that there's no prefix that has multiple types, and check that there are no repeated keys in hashes or lists. In hashes is going to be quite easy because they're already sorted. In lists might be harder. No, it won't be harder because they're sorted too, so it should be quite easy. I just need to think about it a bit when I'm not looking at the screen, so I will do that. Thank you for watching. I'll see you next time.